Hey everybody, Mr. W. This is 4-5 number 61. This isn't too bad of a problem. I think you're probably just thrown off by the definite integral part. So don't forget, to evaluate a definite integral, you do the antiderivative, plug in the top, subtract the bottom. Now to do the antiderivative of this, it's a little tricky. You need to do u sub. Okay, so draw your cloud. Take your u. It's going to be the inside part. This isn't too bad of a u sub. du is 2x dx. Come back to the original. Call that u. I have an x dx. I want a 2x dx. Toss a 2. Balance it with a 1/2. Now I'm here. With my u and my du, I'm ready to do my antiderivative. Still with the 1/2 chilling. I'm going to show you how I like to do this. Oh, wait. Something kind of annoying here. Since we're now writing this in terms of u, we really shouldn't put -1 and 1 here because those are in terms of x. So there's a couple ways to get around this. One way is to just use little placeholders, like u1 and u2. And say, hey, I don't want to call those -1 and 1 right now because -1 and 1 are the bounds when we're talking about x's, not when we're talking about it in terms of u. So I'll switch it back to -1 and 1 when we're talking in terms of x's. We should probably talk about that in class. Maybe we will. Actually, we definitely should. Okay, so I did my antiderivative. I need to switch it back to x's. Here, I'm just going to write like this. Before I plug in the -1 and 1. Okay, so you have to switch it back. Because now I have my antiderivative, and now I'm just going to plug in 1, see what I get out, plug in -1, see what I get out, and subtract them. Okay. Make sure you switch it back to x's before you sub in. Common mistake is to sub in the 1 and the -1 before you switch it back to x's. So now we're going to sub in the 1, we're going to get out 2 to the 4th, 16. That real quick. 2 to the 4th is 16 divided by 8 is 2. We're going to subtract what we get when you plug in -1, which is going to end up being the same thing. So we're going to get out 0. Okay. That concludes this problem. We will talk about this weird technicality with the bounds later. The important thing to remember is switch it back all in terms of x's before you plug in the bounds.